quick on fractions. So I just posted just a few days ago on the page a math poster around perimeter of a shape. And then I posted a question and I just said, hey, let me know of what math skills or math assignments your child is currently working on right now at home. I would love to support you in that. And so we had a fourth grade parent that said their child's working on fractions and decimals. And so I said, I'm going to jump in this week and I'm going to provide some strategies, some tips, some resources around fractions and decimals. So that's what our lesson is going to be on today. Now, before I show you the problem that we're actually going to solve, because I'm going to combine solving word problems and fractions. But the focus of this lesson is going to be on equivalent fractions, okay? And we're going to use a word problem to help us do that. So here's our learning target for this lesson. It says, smart mathematicians can explain why a fraction is equivalent to another fraction by using a visual model. Okay, now there's lots of different visual models that you can use, but I'm just going to show you two of them. The one visual model is the number line, and this is the actual one we're going to use in our lesson today. And then another visual model is called our aerial model. And this area model is where you draw an actual picture or a diagram to show your evidence or to support your conclusion. So in this one, I drew a square, and I divided it into equal parts, and then I shaded it. And as you can see, this square is the same size, but they're divided into different parts. So this square is divided into 6 equal parts, and this square is divided into 3 equal parts. Now, I only shaded 2 of these parts, so the fraction would be 2 out of 6, or 2/6. Okay? This one would be 1 shaded out of 3 parts. So this would be 1/3, okay? Now here's a question you can ask your child. Are these two fractions, 2/6 and 1/3, are they equivalent? Or are they equal to each other? And let me know what they say. All right, so now here's the word problem that we're gonna solve together. It says, Michael rode his bike down a straight road and stopped halfway for water. Sarah also biked the same distance, but broke her bike ride into 4 equal parts to get water. Did Sarah and Michael ever stop at the same place to get water? How do you know? Draw and label a number line to support your conclusions. Okay, so why did I put this in 2 different colors? Okay, I have the purple. This is the story behind what we're trying to solve. And then the blue is the question or the what we're trying to solve. So that's one strategy you can do right there, is to help your child break down the word problem, is use 2 different colors. One for the actual story where they're going to get the information from, and then the actual question that they're trying to solve. Okay, so now let's break this down. So number 1, it says Michael rode his bike down a straight road and stopped halfway for water. Okay, so how would I show that on this number line? So he went from here to here, but he stopped halfway for water. Now I already counted from here to here, and it's 20. Okay, I highly recommend that you get some grid paper. This will really help your child solve fractions on a number line easier, because it has the actual, squares and the lines that they can count and identify where the points are. All right, so from here to here is 20. All right, so halfway would be half of 20. Half of 20 is 10. So I'm going to count 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is 1/2 of the road that Michael rode on. So at this point right here, at this place right here, that's where Michael stopped to get water. All right, so now our next part. Sarah also biked the same distance, but broke her bike ride into 4 equal parts to get water. All right, so now what we have to do is we got to break this up, because they rode the same distance. They both went from here to here, but we got to break it up into 4 equal parts. Right now we have 2 equal parts, and now we need to get 4 equal parts. Okay, so how can we do this? I would recommend you have your child draw another visual model, but this time I would do an aerial model, okay? So I'm going to draw a square. Okay, I'm going to draw a square and I'm going to divide it into 4 equal parts as possible as I can. There we go. 4 equal parts. Okay. Now, I'm going to show you how you can how your child can identify these fractions. So from here to here, let me use a different color. All right. So from here to here, this is 1 out of 4, or 1/4, right? Now, from here to here, let me use a different color. Thank you for being patient. From here to here is 2 out of 4, okay? Then from here to here, what's in red is 3 out of 4, and then the whole thing, okay, the whole thing, put it in orange, is 4 out of 4. Let me use a different color so you guys can see this. 4 out of 4. Okay? There we go. Now you have your fractions that you need to put on your number line. Okay? Our fractions are 1/4, 2/4, 3/4, 4/4. We have 4 equal parts. Okay? So now I'm going to show you how to put this on here. Let's take this chunk right here. Okay? 0 to 1/2. Now, you can tell your child that whenever you divide something in half, you will always have 2 equal parts. The left side is going to be equal to the right side, okay? So if I take this chunk right here and divide it in half, I'm going to get 2 equal parts. So from here to here was 10, okay? Because our whole thing was 20. So from here to here was 10. What's half of 10? 5. So I'm going to count 5. 1, 2, 3, 4, 5, right here. Okay? This is halfway in between 0 and 1/2. Now I'm going to do the same thing over here. Okay? We're going to go in 5. 1, 2, 3, 4, 5, right here. Okay? Now look, we have 1, 2, 3, 4 equal parts. Okay? So now we just need to take our fractions that are down here from our area model and put them up here. So we already know that this is 1/2. Okay? Now your child might recognize that 2/4 is the same thing as 1/2. I hope they do. All right? So we already know that this is the same thing. Okay? Your child might also know that 4/4 is the same thing as 1. That means we can put this over here, 4/4. Now we just have to add 1/4 and 3/4. And looking at our area model, we can see that that has to go from here to here. This is 1/4. Oops, I'm sorry, 1/4. And from here to here, this is 3/4. Boom. Now we have all of our fractions on the number line. Okay? Now, let's go back to our question, what we're trying to solve. Did Sarah and Michael ever stop at the same place to get water? That is the question we're trying to solve. So, and then we're supposed to say, how do we know? And then draw and label a number line, which we did to support our conclusions. Did they ever stop at the same place to get water? Well, Michael stopped right here. He stopped halfway in between. This is Michael. Okay? Now, what about Sarah? She stopped. Every single time you see a 4th, that's when she stopped. Because it said Sarah broke her bike ride into 4 equal parts, and that's when she got water. So that means Sarah got water here. She also got water here. She got water here. And she got water here. All right. So now you can look at your number line and you can obviously see that right here at 1/2 or 2/4, Sarah and Michael stopped at the same place to get water. So you would say that 1/2 is equivalent to 2/4, or that 1/2 is equal to 2/4, because your number model or your number line supports that. Your area model also supports that as well. Okay? So there you go. Now you have a way to show your child how to break down, first of all, a word problem, And then also how to use different area models, different visuals. This is a number line or an area model to help them solve equivalent fractions. And don't forget, if you can, get some grid paper like I have so your child can see the squares and be able to count the lines, and that'll really help them fast track their success with equivalent fractions or fractions in general. All right, make sure you post in this right below. I would love to hear from you what math strategies your child is learning right now. It might not be fractions. It might be something totally different. I would love to support you in that this week. All right, I'll talk to you guys later. Bye-bye.